Learning Goal 5 is about something called a shift pattern when multiplying, and it's actually giving a name to something you've already done in a couple of former learning goals, but we're going to talk about how it means either shifting the numbers or the decimals, and then we're going to bring in some exponents coming up soon, which is going to look really fancy, but it's really not that hard. So the shift pattern is, again, just the way that the digits shift or the way the decimal shifts. So it's one or the other, and I'll show you how you can think about it in two ways. So just whichever way makes the most sense, stick with that one. So when you're multiplying by multiples of 10, and you've, again, done this already in one of the former learning goals, so an example of 25 times 10, you know that you're simply either adding a 0 or you're shifting the decimal, and that's all this is saying. So we've got 10, it's got 1 0, so it means my decimal either shifts one place to the right in this situation, and then I just fill that in with a 0, or I take my number and shift it to the left and fill it in with a 0. So again, you're shifting the same amount of places, just a matter of, do you shift the numbers or do you shift the decimal? Which one do you think? Which one makes more sense? Then hundreds, same thing, only this time instead of shifting one place, you shift 2 because we've got 2 zeros here in the number 100. So 25 times 200. So I would solve my 25 times 2 is 50. Now do I take that answer and I shift my decimal 2 to the right and fill in with zeros, or shift my number 2 to the left and then fill in with zeros? So again, you're getting the same thing. It's just a matter of whether you're shifting the decimal or shifting the number.
I like to think that I'm shifting the decimal. That just makes more sense to me.
I do too, but
hey,
whatever.
So now we are looking at multiplying by multiples of 1/10. And it's the same idea, except you're just shifting in the opposite direction.
Right.
So we have, let's say, 13 times 1/10. We're still going to stick with that number 13, but this time you always start with your decimal at the end first, but then this time we're just going to move it one place value to the left.
Yep.
That's the way I like to think about it. But then also you have your 13. You can think about how you're just moving that number to the right. You still get the same answer again, 1 3/10 or 1.3, but two different ways to look at it. So now you are going to try a few on your own.
Yep.
Yes.
We're not giving you these ones. So.
No. So try these, thinking about that whole idea of shifting and moving your decimal, and we just jot those in your journal, and we'll talk about those tomorrow.
Yeah, make sure you number them so they're easy for us to see.
1, 2, 3, 4. So now one more thing that we want to think about is this whole idea of multiplying with the powers of 10, or these exponents. So you'll see here that we have 10 to the first power, and that just equals 10. But then if you expand on top of that, we have 10 squared, or 10 to the power of 2. And that's like saying 10 times 10, which equals 100.
Yeah, the exponent just tells you how many times you multiply a number by itself. It's not 10 times 2, it's 10 times itself twice.
Yeah. And then in this case, it's multiplying by 10 3 times, since we have this exponent of 3. So that would equal 1,000. And in this case, whenever I think about using 10 in exponents, I always think, well, if there's 3 here, I'm going to have 3 zeros too. That always just helps me. So anyway, now you are going to follow the same pattern. 10 to the 4th power, what would that actually look like? How many times are you multiplying, and then what would your answer be? Just take time to fill that in your journal too.
Okay, so how in the world does that actually apply? Like, why would you need to do it? And actually, you know, when I first saw this, I thought, oh man, this is going to be so confusing. It's really, really simple. When you're multiplying by powers of 10, all this exponent is telling you is how many places you're going to shift the decimal, because you're thinking of it like how many zeros there are. So when you have a number like 4/10 times 10 to the first power, it's like the same thing as 4/10 times 10. And that just is 4. We've solved that before, so you shift the decimal 1 to the right. This is 1 0. So if you do the same thing with 10 squared, again, that's like saying times 10 times 10, which means 40. Or, and again, even this almost looks too much. If there's a 2, and I move my decimal 2, 1, 2, I end up with 40.
Mm-hmm.
So really, this can be simplified by thinking, okay, my exponent is going to tell me how many places I move my decimal. So go ahead and try this one, and I think I'm going to give you the answer to this one. So try it, and
Yes.
then I'm pretty sure we do.
Uh-huh.
All right, I was right. Okay, so again, I'm just sort of stretching it out first. So 4/10 times 10 times 10 times 10, which is 3 zeros, which means we're moving our decimal 3 places. 1, 2, 3, which is where this number 400 comes from. So now you get to try some solo, and I have a mixture of decimals, and I have a mixture with a whole number. So go ahead and number these 5, 6, 7, 8, and try them in your journal, and we will check them out tomorrow. Good luck.